Hi, welcome to Group 6 presentation. Our topic is interference generation using real devices for experiment. There are two members in our group, Wei and Xianshi. First, let's look at the overview, the motivation of the project and the particular application scenario will be delivered. Then we will talk about the related work which give us inspirations on measurement and regenerating interference pattern. And we will talk about the design and how to implement the experiment. In the end, we will give analysis on the result. The motivation is that we want to solve the CTI problem. Nowadays, the use of wireless devices that share the same ISM band causes the CTI problem. This problem cannot be ignored because the ISM band has become more and more crowded. If the devices can generate predictable and well-controlled interference, it will be useful for the engineer to test a new communication protocol or test a new device. For our project, the different in-vehicle and out-vehicle interference scenario has been tested, and we focus on one particular scenario, that is Bluetooth MP3 transfer scenario, and trying to regenerate the interference in that one. For the related work, we got two most important feedbacks on techniques to generate interference pattern and measurement. For the interference pattern, there are three methods are introduced: SDR, packet storm, and modulated and unmodulated carrier. And for the measurement, PRR and RSSI, LQI are applied in the literature. And what's more, the RSSI and LQI can be directly read in the chipon CC2420, which is embedded in the total speed. That gives us great convenience. Let's take a look at the design. The protocol stack is IEEE 802.15.4 and the communication protocol is ABC RIN protocol, which sends packets to area neighbors and use one channel for packet transmission. The simulation tool is Kuya, and we use total speed for the real devices test. Many labs responsible for the data processing limits by the total speed number. We use channel hopping for package transmission. The topology is the sniffer in the center of the network, and the four nodes generate interference and radio to the sniffer. Two laptops are also in use. One laptop sends data through the USB port to the full interferer, and one laptop connects to the sniffer to receive data. Now let's take a look at how the implementation works. For our project, we choose the Bluetooth MP3 transfer scenario as the original dataset. We use MATLAB to process those data and Kuya to construct the interference generator. By deploying four nodes at the interferer and one node to receive the interference data, we will collect the RSS value in 16 channels and use MATLAB to process the data and compare them with the original data and give analysis.
Hello everyone, my name is Xianshi, and I'm responsible for implementation part. First, I'll say something about original data site processing. We will use MATLAB to process the data site to produce 16 channels interference diagrams and analyze them. Take Bluetooth audio streaming in car as example. We can know from the diagram. There is barely no Bluetooth interference in the first four channels. As you can see, they are almost zero. Meanwhile, the usage of different parts of the frequency band by Bluetooth is not uniform. As you can see, the signal power in channel 19 and channel 22 is so different. By zooming in the diagram, we know that the measured interference follows a periodic behavior with intervals of around 30 milliseconds, with each transformation lasting for 3 milliseconds. By knowing this, we can use precise data site and some interference patterns to regenerate interference we want. After that, we use MATLAB program to process Bluetooth audio streaming dataset. The threshold and transformation values are defined to eliminate environment noise and represent whether interference exists or not at that time respectively. For example, we set interference threshold to -88. If the power level of the original data is higher than threshold, it will be considered as interference, and transformation value will be set as 1. Otherwise, the transformation value will be set as 0. There are 600,000 multiplied 16 samples in the original data set, and will take 100,000 samples as input for the limitation of coffee file system flash memory. The result will be stored into different text files as input for simulation in Kuya. And as you can see, this is the code to do the data analysis. When we run this code, the output file will be generated. Based on the channel hopping technology, the 16-channel data is split into 4 input files to realize the best use of the nodes. So we write 4 MATLAB programs to process data and get 4 files. Open the output file. We can see the processed data. We will insert this data into coffee file system later. After analyzing the site, we use packet storming to generate interference pattern in Kuya. In the network well, we can see 2 nodes. Node 3 is the interferer, and node 2 is ISS scanner. We let node 3 generate continuous interference pattern in channel 11, and node 2 scan ISS value in all 26 channels. Then start running. From mode output, we can see ISS scanner receive ISS value in channel 11. Besides continuous interference pattern, we also generate periodical and increment interference pattern. By using MATLAB, we can see the diagram of different interference patterns. The first one is continuous patterns. The second one is increment interference pattern. The third one is periodical interference pattern. We will use these patterns combining with the result of dataset analysis before to regenerate interference. From network well, you can see the topology of our network. One node with ISS scanner is in the central, and 4 interferers are around it. All of them are assigned to sky mode. Interferer uses the processed data site as input, and combine with periodic, fixed patterns to generate interference we want. The receiver with ISS scanner function is used to capture ISS value. CC2420 radio has one beneficial advantage is that the ISSR value will be shown automatically through the process. As you can see, We use coffee file system to load data into each interferer node. Now, I'll insert 4 generated files into each node. And then start the simulation. You can see that all nodes start running and the ISS scanner shows the ISS value detected in different channels. Now we pause it. From mode output, we can see the printed ISS value. -19 means there is no interference in this channel. Other number above -90 is the signal power received in this channel. We can also see channel hopping from our mode output. Takes node 4 as example. We can see it jumps from 20 to 22, and then it jumps to 20 and 21. By this method, we can use 4 interferer nodes to generate 16 channels interference. Then we start again.